Hello everyone, welcome to my channel. Today I'd like to talk about what I believe are the top 5 performance tuning culprits for databases. At number 1, I have indexes. Number 2, I have stats. Number 3, blocking and locking. Number 4, memory. And number 5, IO bottlenecks, right? The format I'd like to use for this video is first of all, do an introduction of all 5 components and then do a demo of like how I fix these issues when I encounter them, right? So I'm just gonna go ahead and get into it, right? So let's go ahead and start off with indexes, right? So when we say missing indexes, it doesn't mean that the tables are not indexed, but we are specifically talking about, does the table have the right indexes? We have two types of indexes here: the single column, right, and the composite. Okay. Some tables need single column, some need composite, some need a combination of both, kind of like a hybrid structure, right? And even sometimes you might have both and your queries are still not performing at an optimal level because you just don't have the right indexes. In order to be sure that your indexes are right, there are a few things that you must take into consideration, right? The first thing is the type of operations on the database, type of operations. The second will be your type of queries, right? And for the queries, you are looking at your where clauses. Okay, we are looking at join columns and uh, where clauses, join columns, and order by columns. Okay, if you build your indexes around these main components, then you have high performing indexes, right? And we know that indexes are kind of like the GPS. If the indexes are built at an optimal level, the database is going to be functioning at, you know, optimal level, which is good. So at second place, we spoke about stats, right? So stats, what are stats? I like to look at stats as inventory, right? Inventory to the database. If you're, manager in a restaurant, for instance, and you knew exactly how many steaks and vegetables you had and where they are, it makes you plan better for the week, right? The same thing. The optimizer, needs to have up-to-date stats on the database so it can plan better and execute better as far as creating routes to the data that you're querying, right? So stats are very important. People tend to minimize the importance of stats. So still stats, definitely not a good thing for query optimization in the database. Okay. So in third place we have blocking and locking. In some environments, this might actually be the first on the list. But if you build your environment the right way, it shouldn't be number one. Okay, so look at blocking and locking as traffic lights, right? If someone is making updates on a specific row in a table, it gets locked, so we don't have data corruption. And if, take for instance, you have a batch query updating a million rows at a time, you know, and nobody can access those rows, then we have a long queue, right, waiting for those updates to complete. And then worse still, if you're in an environment where you have bad queries, queries without commits, things like that, or queries that lock a bunch of rows unnecessarily, things like that. So, blocking and locking, we know with deadlock situations, those are almost, always taken care of automatically, but we're looking more like manual steps. So with blocking and locking, you have to look into that. It's possible that you have a lock on the table, which is not being committed, it's just idle. So you have to take care of that. So number 4 will be memory pressure. Okay. Memory pressure. What does this mean? Um, so in an environment, right, you have your buffer cache, right, query plan cache, and work memory, right? So the buffer cache keeps, you know, data that you query most often. Think about it like having a work desk, and the projects that you're working on currently, you have it displayed on your desk. If you have a bigger desk, you can have more files open, so they're easier accessible, right? And then the query plan cache, you're keeping plans that you know, if you've been to a place before, again with the GPS analogy, that route is stored, so you don't have to find a new route every single time, right? And then work memory is like where you like complex transactions are handled in the database, right? So if all these three are correctly allocated, you should have an optimally functioning database. If not, you're gonna have some issues. So that will be the fourth thing I would check, and the fifth will be I/O, right? What are we looking for when we're talking about I/O? How fast your database can read from storage, right? Even if you have, the fastest CPU possible, if you can read from storage, at an optimal level, then your database will be slow. A couple symptoms for this would be maybe queries that were functioning well in the past are no longer functioning well, high disk queue lengths, things like that. Also, if you have, you know, high CPU usage is low, but the response times are high, things like that. So basically, when you're reading a lot more from disk than you should be, and maybe your storage might be undersized, or maybe you're running queries and competing with backups at the same time, things like that. So this would be the top 5 things I'll be looking for. Okay. So let's dive right into it and do some work. Let's get our hands dirty. So for this exercise, I'll be using a Postgres container on my personal computer. I have a MacBook. See, the terminal is open. I have a few windows open. If you need help setting up a work environment on your personal computer like this, let me know in the comments, and I will post a video explaining how to do so. Okay. Um, so I have a Postgres database here. I will do all the scenarios with Postgres. In subsequent videos, I will interchange between PostgreSQL Server and Oracle. I can't do all three. The video will be super long if I had to do that. So I'm just gonna get right to it. Okay. The first scenario we're trying to test is missing indexes. Okay. So I'm gonna go ahead and create a table called employees. I have the scripts. I will keep a link in the description as well to GitHub repo, or you can have this. You can get the scripts and follow along. Okay. So I've just created the table employees. I'm going to go ahead and do an insert into the table. I'll insert 5 million records into the table. Okay. And just wait while the records insert. It'll take a few seconds. That 5 million records. Let's wait for that to execute. Okay, so we got our 5 million records inserted. So we're gonna go ahead and try to query this table. I will set timing on. so we can all see in real time how long it takes to query the table. Go ahead and type that in. Okay. Yeah, so let me do that real quick. So turning on, okay, and then I'm gonna do a select from the table. And just pay close attention, see how long it takes. Okay. So it took about 802 milliseconds. Now I'm gonna extract the explain plan so to see the path that the optimizer took to execute this query without indexes. So I'm gonna go ahead and paste that in. Okay. You can see that obviously no index scan is there, full table scan, because we don't have indexes. And the execution time 433 milliseconds. So I'll go ahead and create an index on that table, and then we can do a comparison after the fact. Okay. Okay, we have the index created. So now let's go ahead and try to select from that table again the same query. Okay, and you see now we're able to get that done in 4 milliseconds. Okay, so let's run the explain plan for the query. You can see that an index scan was done, no full table scan, shorter plan, more efficient plan. That just goes to show you the importance of having indexes set up. Okay, so we should always think about that. Always have indexes set up, the right indexes. Again, this is just a little illustration, right? I mean, this table barely has any, let's see how many columns on the table. Employees. See, barely, I mean, there are tables with thousands of columns and billions of rows, right? So this is just a microcosm just showing you the potential of indexes. Real world scenario, real production environments, it's a lot better having indexes. And you can see, even with the small table, you can see how much faster, execution time is with indexes. So I'm going to move on to the second scenario, which is testing having statistics. Okay. Now, this is going to be a little harder to show in Postgres, because in Postgres, stats are gathered automatically through the auto vacuum process, right? Now, depending on how you set the parameters, usually if your data, moves 10% or 20% from the previous time stats were gathered on the table, depending on the parameter that you set, Postgres will automatically gather stats through auto vacuum process. Okay, so this is more, I say, prevalent with Oracle and SQL Server, but we'll find a way to do this test in PostgreSQL in a way. We'll try to disable the gather stats process and see if that, the auto vacuum process, and see if that, will allow us to do this demonstration. Okay, so I'm going to create another table called order history. Okay. you know what, I'm going to modify this table. Go to here, author underscore history. Okay. I'm going to create the table again. This time around, I will put in a clause there where auto vacuum is false. Okay. Okay, so we created the table. We don't want it to auto vacuum. Okay, we want it to only do so when we create stats. I mean, again, this is not very very prevalent in Postgres just because auto vacuum runs, but also you have to be cognizant of that fact. So if you're running your Postgres on EC2, where you have to actually set the parameter, you set the parameter that actually makes sense for your environment. Now, if you're running an RDS instance, obviously RDS is optimized and would, run that vacuum process for you. But with EC2, it's a little bit more manual process. Even though it will still use the default values, if you have tables that update, every so often, then you might want to have the parameters set correctly. So it's just something to think about. Okay. So I'm going to go ahead and insert into this table. Okay, we inserted 1,000 records, right? Okay, and I'm going to create an index on the table. You all know the importance of indexes, so I'll create an index in that table, and then I'll go ahead and analyze the table, right? So the optimizer knows exactly how much inventory is in that table that we discussed earlier. Okay, go ahead and paste that in. So analyze history, and then what I'm going to do is I'm going to check the stats now. Obviously, after analyzing, I expect the stats to be up to date. So I'm asking, hey optimizer, how many rows you think are in that table? Okay, let's see what optimizer says. 1,000, which is pretty accurate because we got a stat. So I'm going to go in right now. I'm going to update the table with much more records. Okay, we add about 2 million more records. The table. This might, take a few seconds. So let's just wait. Let that update. Again, I want us to do this in real time, so gonna be a few lags here and there, but I just want us to experience this in real time. Also, if you're working on your computer, you don't have to pause the video every so often. We can just work together. So let's wait. Okay, 2 million records inserted. So now without gathering stats, I'm going to go ahead and run that query again and ask the optimizer. Fingers crossed. Again, this is PostgreSQL, so the stats may still be up to date. I don't know. But just for the sake of demonstration, try to turn it off. So, well, you got it correct. Again, it's PostgreSQL. So, gathering stats is not, it's not a big deal with PostgreSQL, but it is with Oracle. Okay, I'm just gonna go ahead and try to let's add another 5 million records and see if optimizer will get it right again. Just curious. Yeah, and one thing too, you have to know your database flavors. Oracle is a beast, but there are certain things Postgres does better. SQL Server is also good at certain things, like versioning is inbuilt in SQL Server. Postgres doesn't have it. Just a few things here and there. Optimization speed. I think Postgres has a great engine. compared to Oracle and SQL Server, I would, for certain types of transactions, I'll pick PostgreSQL. But just in general, Oracle is very robust. So, and again, knowing your databases helps you with choosing which database to use for what workload. I mean, if you, as a DBA, you should always be able to provide your 5 cents on which database platform should be used when, where, if you have that opportunity. Postgres is a lot cheaper now than Oracle, way, way cheap. I think that's open source. So most people are like going towards PostgreSQL now. Okay, that updated. So we don't have to worry about stats really when it comes to PostgreSQL. You know, that's a good asterisk you can make. So I'm gonna go ahead and do the third demonstration, which is the blocking and locking scenario. How we're gonna do it this time? I'll have 3 terminals open. I'm going to have a transaction running in the first terminal. I'm going to try to update on the second, and hopefully the lock works, which is what we're trying to demonstrate. And then I will query for the blocking session on the third terminal. So yeah, let's do that. I'm going to create a simple table for this illustration. So let's go ahead and do that. I'm going to create a table called account balances. Okay. Let's go ahead and do that quickly. Tables created. So we're gonna do a random insert, just 1,000 records into this table. Okay. No, actually it's a multiplier, so 1,000,000 records. Yeah, 1,000,000 records. So I'm gonna set auto commit off again. PostgreSQL has the default is auto commit is on, and Oracle auto commit is off. So for the sake of this example, I'm gonna turn auto commit off for Postgres. Okay. There are so many reasons why a transaction can get locked, okay, or like blocking can occur. Now, commit is one reason. Now, given that auto commit is on in Postgres, that's one scenario where Postgres passes. But what if I was doing a bulk update, on 1,000,000,000 records, and then at that point nobody else can access the transaction? This is just an easy example. I mean, can access the table or rows. So this is just an example, to kind of like show what blocking does and why it's important to check for it when somebody complains, oh, my query is running slow, right? So I'm gonna go ahead and update the first 50K columns here. Okay. Now that update actually worked. Okay. That update actually worked. Let's keep it open-ended. All right. I'm gonna do an open-ended query. Okay. So that the transaction doesn't commit. So let's do it this way. Okay. I'm gonna do. I think I have one query, similar query, here somewhere. Okay, if I can't find it, I'll type it out. Okay, looks like I can't find it, so I'm gonna do begin. Um, oh, actually, it didn't commit. Oh, that's my bad. Okay, that's my bad. I was wondering because it said 50,000. That confused me a little bit. Okay, so let's go ahead and set timing on this side. The server output confused me a little bit, guys. I'm sorry. Okay, set timing on, and let me try to do an update, to account ID number 25,000, which is basically covered in the range, right? So let's see what happens. You see it's stuck. It's stuck because of the lock that the first transaction did. So this could be somebody on the front end running a query and they say, oh, usually when I run this, it's done in 5 seconds and it's been running for 30 minutes. This is the kind of scenario. So, I mean, again, depending on the environment that you work in, this could be the first problem that you always encounter. Again, it's a function of how your queries are written, how they interact with each other, how your data is stored, a lot of things. So I feel like knowing your environment helps you kind of like reorder, these 5 issues. But just from my experience, this would be number 3 I would go to. Okay. So you see this update is hanging, right? So let's go ahead and run a transaction. Let's run a query on the third terminal. Let's try to figure out what is holding what back. Okay. So this would be a query that you would run to figure out, oh, what's going on? Like, why is this? And then you can see what is blocking what, right? You can see where the block is. The first transaction is blocking the second. And until the first one is committed, the second is not gonna go through. It's gonna remain stuck. Let's see what happens when we issue a commit here, okay? We're gonna issue a commit on this transaction. Commit it. What happens here? See? Immediately. So that's just an illustration of how blocking sessions work.